So you were given an equation that looked like this. You had a term that had a coefficient with a variable, and you were given two different sets of numbers. These are considered like terms, even though this is a whole number and this is an improper fraction. So technically, when you're given like terms, you have to combine them. But I can't simply add 3 plus 9 over 7. What do you remember about adding fractions? Kristen? You have to have a common denominator before you add them. So what I did was I made an arrow because I'm going to convert each of these fractions. Well, 3 is not a fraction. How could I change that to a fraction? Chelsea? 3 over 1. But I'm not done yet. Now I'm going to convert. What is the common denominator between 1 and 7? What can both numbers fit into nice and evenly? Lily? 1 can fit into 1, but can 7 fit into 1? You said 21? Go lower. Think lower. Someone just said it over here. Michael? 7. Okay? 1 can fit into 7 times, and then 7 can fit into itself. Okay? So I'm going to change each of these so they have 7 in the denominator. Now, I have to think, how many times can 1 fit into 7? I just barely said it, Kristen. 7 times. Whatever you do on the bottom, you have to do to the top. So you have to multiply it by 7. What's 7 times 3? You can just say it out loud. 21. Does this change at all? No. Now I have 2 like terms that I can easily add. What's 21 plus 9? 30. So I have 30 over 7. Now I'm going to make a line here because I'm going to pretend that we just solved a big expression and now what we have left is 30 over 7 equals 2x plus 3. I am just making this up. You were given something that looked like that. And to me, what I see right off the bat is the letters on one side, which is great, but I have a number over here and I have a number on the left-hand side. Now that fraction, to me, it looks kind of ugly. I don't like dealing with fractions. What can I do to get rid of this fraction? Think about the fraction bar and what it means. Michael?
30 divided by 7.
Well, that's what this says. It says 30 divided by 7. So what's the opposite of dividing? You can just say it out loud. Multiplying. So to get rid of this 7, guess what I have to do? I have to multiply the entire term by 7. And we've learned that whatever we do on one side, you have to do to the other. So if I'm multiplying this by 7, guess what? You have to multiply this entire thing by 7, not just the 2x. You have to multiply the whole thing. Okay? Oops. I have to put my 7 there because I'm running out of room. Are there any questions on that part so far? Because I'm just going to keep on cruising along. Okay. I want to look at this. Why does this cancel out? Remember, 7 as a fraction. Yes, Kristen? You can go ahead and explain. You're right. And some of you might go, well, why is that? Why do they cancel out? Think about multiplying fractions. There's 2 different ways you could approach this. That's what I have. That's what that's telling me. I have 7 over 1 times 30 over 7. Now, I can multiply straight across So if I have 30 times 7, that is 210. And then 1 times 7 is 7. And what is 210 divided by 7? It's 30. So I have this and this is gone, and I'm left with 30 wholes. Or another way you could look at this is remember to cross multiply. Looking across, 7 can fit to 7 one time, so those cancel out, and you're left with 30 over 1. Okay? That's why this works. That's why you're left with 30 equals 14x plus 21. And now you're left with something that you're used to seeing. You now can solve for x. Are there any questions? Okay. That will be the end of my video.